Okay, so we will just quickly go over this. So we have covered these concepts. I hope these things are clear to you. If you have any question, you can ask. And we have discussed all this, right? Client server architecture. So can you tell me where exactly Python runs? Does it run on client or does it run on server?
Server, sir.
Okay, very good. Predominantly works on server, but there is you can use Python even for GUI development. So in that case, you can build GUI using Python as well. Okay. So the question is, what is GUI? What does GUI stands for?
Graphical user interface.
Yes, very nice. So there are two types of GUI. One is web GUI or web UI. Then there is a desktop GUI or UI, right? So graphical user interface or user interface. So do you know the difference between these two?
One is for website and the other for maybe softwares on computer.
Other one is for software. Even websites are softwares. So one is actually this web UI is for browser. Okay. So we have so many internet browsers, right? Chrome, Safari, Internet Explorer, then Edge from Microsoft. Then we have discussed about that. I think Opera and all also. Some of you use Opera and for Firefox as well. Firefox is again a very good browser. So now this web UI is what you see on the websites. When I say desktop UI, it is all desktop apps which are available on our computer, like your MS Office apps, like MS Word, Excel, right? These are desktop applications. You just launch it, they don't run on browser. They run on the desktop. Okay, so you can use Python even to build these kind of applications as well. Okay, so Python usage is at so many places. That's why it is known as general programming, general purpose programming language. Okay, so I hope desktop GUI is clear to you.
Yes, sir.
Yes.
Any other example which you can give me for desktop UI?
All the apps on our desktop on a
All
computer.
the apps, excellent. Yes, all the apps on your desktop are desktop apps. Even your file explorer or your what is that? Your email, Outlook, all those things are desktop apps. Even I have all these apps which you see. These are all, they will run on all, they will have their own desktop UI. Okay, so there will be desktop apps. They have desktop GUI. Right, so moving forward, and Python version 3 is what we will be going forward. At the moment, you may have Python 3.10, but between Python 3.8 and 3.10, there will be minor differences. So we have spoken about Python implementations. We have discussed about compiler and interpreter as well, isn't it? Or we haven't? Okay, so
I think we have. I'm not sure.
Okay, so yeah. So can you tell me what exactly is a compiler and what exactly is interpreter? Why they're required?
The computer only understands like binary, so the program which we write in Python should, or any programming language, should be first converted into the binary code which the computer will understand. So that's where compiler interpret.
Yeah, so we human beings, we understand high-level language, high-level programming language. Okay, so computer understands binary code, which is called low level. Okay, programming language. So initial days of computer, we used to, like human beings used to give commands in like zeros and ones, like, so you have space, you will have holes, you will have this kind of card, and you will have pattern. So there'll be holes like this, but then in some place you may not have holes, right? So like that, you would give instructions to programming language, instructions to the computer in earlier days. So they used to punch the card.
So they literally used binary in
Yes,
the early.
exactly. They literally use binary. And then when they little bit evolved from this, they started giving the instructions as zeros and ones like this, right? It was too tedious. Still, it was too tedious. Then they came to assembly language. Assembly language. Okay, so this was a little better. So instruction would make sense like A5 and A0. Still, it was making sense to them. Okay, this means certain things. So instead of binary, they were using hexadecimal, which is still okay. Instead of writing so much, hexadecimal, hexadecimal is a number system. So you know the number systems, right?
Yes, sir.
Okay, so we have binary, then we have octal. Then the one decimal system which we use is called decimal.
So octal is 0 to 7.
0 to 8. 0 to 7 actually, yes, you're right. Total 8. And this is 0 and 1. So total is 2. Yes, you are right. So decimal is 0 to 9. So total is 10. And then we have hexadecimal. Can you guess from what to what?
0 to 9 and E to F.
Yes, very good. Yeah, 0 to F, right? So that's very good. So total is 16. Okay, so all these instructions were converted into this. It became still easier, right? But still, it was not very intuitive. Then, so it was called assembly language. Then they progressed to high-level language, and even though there were other high-level programming languages which came, but C was the first most prominent programming language, which was very nicely built. And C, even after like 40 years, it is still in usage. People still use it. It is so nicely built. And then all rest of the programming languages have taken some learnings from C, how the C works. They have taken some learnings from C. So C was the first high-level programming language, which was quite popular. And then can you tell me examples of other high-level programming language?
Java, Python.
Excellent, excellent. Yes. So all that which we use these days, we work in high-level programming language because it doesn't make sense to go back to binary code or even to assembly language, right? Even when you're doing system-level programming, still it is done C and C++. Okay, even system level programming is done in that. Okay, so
what is system level? Like, what does it mean?
okay, that's a good question. So a system level means your operating system, right? Operating system software which you write, it will consist of your drivers. Okay, uh, device drivers which control the hardware, right? Which control the hardware. You will have like device drivers, then you will have firmware. Firmware is called your motherboard. Firmware software. All these things are system level programming, okay, which you do for system programming.
Yes.
Yeah, so I will just erase this. Now, so system level programming yeah, so then the embedded systems, right? Then embedded systems are embedded systems, right? So any example of embedded system can you think of?
Arduino.
Yes, very good. Embedded system.
So can we take PCB board as example?
PCB board, no, PCB board is just for making circuits. Okay, PCB board is just for making circuits. Now, what you run is a different thing altogether. What program you run, either you run C, Python, Java, all those things are a different thing. PCB board is just the your circuit, electronic circuit. You can run any programming language, because eventually what will run on this PCB, or for that matter on any computer, eventually it will run just zeros and ones. Okay, eventually it will be zeros and ones, that because that's what it understands. And why zeros and ones? Even zeros and ones it does not understand. It's an electronic device. How does zeros and ones make sense? Any idea about that? What is the zero?
0 is off and 1 is just on.
Okay, yeah. So it's not really off, it's low voltage.
Okay, yeah.
And high voltage. Off means the circuit is not there. Okay, so very good. Yeah. So this is what electronic device will understand. So it will be like this. Signals will be like this. These are the digital signals. Okay, so you have like this, then you will have like this. So these are eventually treated as zeros and ones. A lot of logic goes inside, and then eventually whatever we see on the screen is a translation of all this. And a lot of parts are there in computer which we don't know. You know this the CPU, right? This is a CPU. This is responsible for executing your instructions, right? It is responsible for executing your instructions. And it has, how does it execute your instructions? It has a lot of logic gates, right? It has a lot of logic gates where you are giving two inputs, and then accordingly it will give you output, right? So a lot of things are there in the hardware, which along with this electronic signal, it all works. And our computer is becoming way and more powerful, because we are able to pack more components in this. And this pretty much components are, the main component are the transistors. These are the transistors, okay? And a CPU these days, we pack like maybe billions of transistors, billions. And CPU may be this much, right? Can you imagine the manufacturing process which is able to push these many number of transistors in this bigger chip, right? And transistor, you get a physical ones also. It has 3 terminals. You may have probably.
The NPN transistor and PNP transistor.
Yes, PNP and NPN. Yes, very good. Yeah, so you guys are aware of robotics as well, right? So yeah, these are the transistors. So like this is discovery of transistor was the defining moment for computer science, for building these powerful computers. Okay, so this is what is all how it works. So now coming back to embedded system. Now embedded system, the code which we write, embedded systems are nothing but the small systems which you see, like your microwave, right? You have a small display, then you have smart TV, right? So they have small softwares which are running, which control that, which lets you control the system. They're called embedded systems. Okay, and predominantly you use C programming language, because you don't have to give a lot of instructions, just basic some commands which are there, right? Maybe 20-30 options will be there for you to control on the remote. For smart TV or for television, you will have that kind of.
So in what language is C written?
Okay, that is a pretty nice thing. C is written in C only.
Then how's the first C written? The others.
Yeah, so C, okay, so that is that is a catch-22 kind of thing. So this is what it is. C is written in C only. Now probably the way they wrote is they kept on writing little bit, and then from that they converted. They wrote more language features. Okay, so that is how it is. Now I don't have a lot of details about it, but yeah, C is written in C. You can maybe read about it. Okay, you can read about on the internet. Okay.
Yes.
Okay, so fine. So we were talking about compiler interpreter. As you rightly said, eventually it has to be converted from high level to low level language. Now, so that eventually, so both of them do the same thing. Both of them do the same thing. Now, the way they work is slightly different. Do you know the difference? How compiler works and how interpreter works?
So compiler compiles it.
Yeah, and what does interpreter does? Okay, so what will compiler do is you give it a source code. Okay, source code is nothing but your program. You give the source code, which will be in form of a file, maybe .py, right? So you give it a compiler. Not in this case, actually, Python is not a language. So let's say it is a C file, source code.c, and then it will convert into binary file. Okay, so it will convert into binary file. So it will be in something binary, right? So you first get the binary file. This is a step one. So what you follow two-step process. So step one is converting source code into binary. And then step two is executing. Okay. So let's say if you have 100 lines of code, all that code will be compiled and converted into binary, and then you get the binary file and then you execute it. Fine.
Okay.
Right. And then what interpreter does? Interpreter will actually take the source code. It will take line by line. It will open the file itself. You start reading line by line. Take one line and execute it. Take one line and execute it. Right? So this is how it works. Fine. So now this is the process. So we don't do like compilation first and then execution first in case of interpreter. So now,
So then how does it execute the file, the line?
okay, so what will happen is, as you understand, so it is the file which will be loaded in on the RAM, right? It will be loaded in the RAM. Okay, and this thing will be given. So line by line, it will take as an instruction. This will be decoded, and after decoding, now it has understood, okay, what exactly. So once it is decoding, it will convert into binary, and then it will execute it. Okay, so it is, so actually internally it actually creates something like bytecode also. Okay, it converts bytecode also, but bytecode is, again, it's not binary code. Okay, it's not a binary code. It's not a binary code. Okay, so still this bytecode instructions it is going to it will be still it will be somewhere intermediate between high level and low level, and still it is going to give it will still work in this way. But this all happens internally. We don't have to do anything about it. So that's why we write Python and we execute the file. So the internal conversion into bytecode and then execution is all taken by one program, which is the Python. Python command is going to take care of both for us. Okay, so this is internally it happens like that. In fact, there is in the reading material you'll find some mention that how exactly, I think in the second chapter there's a mention that how exactly things work in Python. Okay, so you can maybe read about that. But pretty much the top level thing is that Python is an interpreted language, and interpreted language means it's a one-step process for us. Okay, execution and basically converting the instruction into machine code instruction, and execution happens line by line. Okay, line by line. Fine. Is it Clear or not?
Yes, sir.
Clear?
Yes, sir. Clear, sir.
Okay, okay. Right. So now the question is, which one do you think will be faster? Compiler,
Interpreter.
interpreter. Okay. Okay. So Sohan says interpreter will be faster.
So, but the line by line thing, so I think the interpreter will be slower.
Interpreter will be slower. Okay.
So the compiler converts again, it converts into binary again it will. So it may be slower.
So compiler, so Sohan says compiler will be slower and Rehan thinks compiler will be faster, isn't it?
Yes, sir.
Okay, okay. Right. So see, the thing is, see, overall time which we take as a human being, yeah, in that case, interpreter will be faster because for us, it doesn't take time, right? It is not a two-step process, it's just one-step process. So in that case, interpreter will be faster as far as human being is concerned. But when it comes to execution of the program, compiler is faster. Execution of the program, compiler is faster. And this conversion, the conversion of I'm saying creating of the file and giving it to the compiler, the two steps is just one time, but the execution of the program will run so many times, right? 1,000 times, million times, still the system is alive, right? So eventually what it means is compiler is actually faster. Okay, so compiler is faster because think about it. What interpreter is doing is it is taking the line on the fly at the runtime when I'm running, right? So when I'm running, so at runtime itself, it is taking the line, converting it into binary code, and then executing it, right? It's like I've been given fruits, and then I have to like peel the fruit and then eat it. Now the person who gave me the fruit, it's easy for him. He just gave me the fruit, but I have to peel the banana, cut the apple, and then eat it. Now, so for me, it's like interpreter. So for somebody who is getting ready-made, peeled, and chopped food, he just has to eat, right? So he will be faster. So that is what is compiler. Okay. So compiler are actually faster. Is it clear?
Yes, sir.
Okay, good. So coming to that, so you can think about it. You can read about this thing, and yeah. So this is the difference. Now you may have question if compilers are faster, why Python is not a compiler, right? Why
Yes.
Python is not using compiler? Okay.
Like as it executes each line at a time, that could be helpful in like debugging and like finding errors, maybe.
Okay, okay. Yeah, I'm saying finding errors, it is a little bit easier. But see, software development process is just one time, but software will be running for numerous times. We are debugging, we are fixing bugs, or we are writing code. That is all one time it is happening. But then when the system is when the software is in the production, it is running n number of times, like it is running millions of times for months, for years, right? So, so Python was actually initially not designed to be used in such kind of full-fledged manner. Okay, so earlier it was designed, okay, you just want script. So any interpreted language, it's called script as well. Okay, so Python code, many times you can say Python program, you can also call Python script. So it was just, okay, you want to do some production job, like you want to write a few lines of code, which will maybe check server, right? Which will ping server and check whether the server is alive or not. So Python was meant for that purpose. So it was that, okay, I don't have to compile, I just need to check, do something, right? So it will keep on doing that. So there, the speed and all execution didn't matter. But now there is a language called Julia, which is like Python, but it is a compiled version. It's a compiled version. And it is gaining traction. Okay. It is gaining traction as well. But yeah, I'm still in the nascent stage. Still in the nascent stage. If you look at GYPL.
So why is interpreter better than compiler?
Why is interpreter better than compiler? Okay, so to do this kind of job, which is just to write a quick code to do certain things, like you want to write quick code to check whether emails are you're getting emails or not, you're checking messages, some production tasks which you want to write, right? So there, uh, interpreted based language will be better, because for C, then you have to compile it and then you have to run it. It's a two-step process. You're not worried about speed. You're not concerned about speed, because we will come to that, what really speed means. But I was just thinking about, see, Julia, the adoption is actually 0.48%, but it is increasing. Okay, it is increasing. So this is something which people have seen. Okay, yeah, Python is nice and it is used in production. So why not create a new language? But again, it will take some time for it to come. Yes. So now we are coming to that about the speed, right? So we are saying, okay, what is the benefit of when the interpreter is slow, Python is slow? What is the benefit of having Python? Why should I run in the server? So, isn't it? Right? If Python is slow, why should we run on the server? Our server will also be slow. So let's say we have this server where we are writing the code. Okay, one side it is Python, and one side, let's say, is a compiled language, maybe it is C++. Okay, so we are writing the code, and then this code, now we have this client which is connecting to this server, and it wants some data. It wants some data. Now in that case, what will happen is Python is going to execute this. It will fire the query on the database, you get the data. Maybe let's say it took 100 milliseconds. Whereas C++ actually took 20 milliseconds, right? 20 milliseconds. C++ is like 5 times faster. I'm just throwing a number. It may not be five times faster, but in different context, it may be even more faster. We'll come to even that context also. Right? So you see, oh, there's a huge difference. There's a huge difference. 5 times faster, right? Now, if you look at this, okay, so you have saved almost like what? You've saved 80 milliseconds in C++. But then what about the transit in the data? Here you're spending maybe 1 second to send the request and 1 second to get the response. You're taking 2 seconds in doing that. And I'm talking about best latency, best broadband, reaching out to a server in Mumbai or maybe in North America, and then you coming back. It's still taking that much of time. How much this translate? This is like 0.1 second. So the overall time is 0.1. And C++ that point is 0.02. This is not much difference. Speed, overall speed, if you look, it is almost like 99%. There's not much difference. So if it is whether it is, if I'm getting my response in 2.1 second or 2.02 second, it doesn't matter to me, isn't it?
Yes.
Yes. So Python is actually useful for these kind of scenario. That's why Python is not useful for all the kind of scenario, right? So that's why Python is not used for 3D games. Okay, Python is not used for 3D games, but it is very good at 2D games. Because in 3D games, you will have a lot of CPU intensive job, which you'll be doing, CPU intensive job. No, you will be running a lot of code. Okay, that's where it is not useful. So Python has specific use. Every programming language will have its own specific purpose. Fine. So why Python is beneficial? Python is beneficial because the code which is written is much more intuitive, and because since it's much more intuitive and it is open source, a lot of people started adopting it. A lot of scientists Mathematicians started adopting it, and its library became really rich. Python's library is massively rich, and that's why Python becomes a default choice for AI and machine learning. Right? Eventually, uh, eventually, because of all the popularity of Python, richness of the Python, it is becoming more and more popular. Why? Because it was easy to understand, intuitive, not much of headache in running that code, simple, quick things. Scientists want to do quick things, right? I want to do some calculation, let me do this quick thing. They're not very bothered about whether it is taking 1 second or 1.01 second. It doesn't matter to them.
So
Okay.
even the syntax of Python is very much easier than syntax of C.
Yes, syntax of Python is much more easier than syntax of other programming languages. That's correct. That's correct. And with easiness, it does not mean it's not powerful. It's extremely feature rich. It's very, very powerful. And the number of lines of code which you write in C as compared to Python, as compared to Java, if Java is taking 100 lines and C is probably taking 200 lines, Python may take maybe 30, 40 lines. It is so small code which you write in Python. Okay, so fine. Moving forward, so I hope it's clear that why Python is beneficial, or what is the purpose of interpreter. Every people have their own job, right? Everybody is not Usain Bolt, but it's not that only Usain Bolt lives in this world and only Usain Bolt is useful. That's not the case. I hope it's all clear to you.
Yes, sir.
Okay, good. Yes, so you can read about all this, and you can see that Python eventually converts into bytecode and it runs inside it. And this is similar to what Java, even Java follows this kind of thing. Instead of PVM, it is called JVM. So PVM is Python virtual machine. I'm just telling you these terms. You don't have to worry about it. These are just terms.
So the PVM is in the desktop itself, right? Like in the CPU itself.
PVM is so whenever your program starts, it gets its own environment, which is called runtime environment. Runtime environment. Okay. So it's like a container. Runtime environment is a container. We also call it the process. Okay, because everything has to run inside that container. You start it, then inside that container, you allocate some memory, you allocate some space. This is your space. You do whatever you want to do here. It cannot be doing random things here and there, right? So Python virtual machine is PVM, which will actually really execute your program. Finally, it will execute your program. Okay, so this is what it is. So many times we say that the Python is running my code. Sometimes we say PVM will call my code. PVM will look into this. Sometimes we say that. In Python context, we don't use much, but in Java context, we use a lot. That okay, JVM is going to call this method. JVM is Java Virtual Machine. Virtual machine is nothing but a container, a space inside which the program is going to execute. It's not going to be spread around everywhere. Okay. Anyway, so this is just concepts to understand. You will not be really working on them unless until you start working on Python code itself, and say, which is some time from now. Okay, guys. So I think I hope all is clear. If you have any question, you can ask. And these things, I think we have discussed about it. So instructions are fetched, decoded, and execute. CPU is going to do this very fast, execute, fetch, decode cycle. Okay, at a clock speed. And that clock speed is what you see in gigahertz. Okay, all clear?
Yes.
Okay, good. Students,
Yes.
so we will write a program today to swap a number. So to swap two numbers. Okay, so I'm not sure if you have already written this program, but if you have written, that's okay. You can just guide me. X is 10 and Y is 20. Okay, so I want to swap these two numbers. How do I do that?
You can either create a third variable
Excellent. We create a third variable, and then what do we do?
and assign the value of one of the variable to that.
Okay, let's say I assign X to that, and then
Now the x's value is already in z, so we can replace the value in x with the value of y.
excellent, excellent, Rehan. Yes. So yeah, so that's great. So we do that, and as the last step, we will say Y is equal to
C.
Z, right? So X is 20 and Y is 10 now. So now my question to Sohan is, why can't we do simply like this? We want to just swap. Okay, let's do this. X is equal to Y and Y is equal to X. So Sohan, why we cannot do something like this?
If we do like that, the value will be same for both of them.
Okay, okay. Yes, you're right. So what happens is, this is what kind of a statement is this?
Assignment.
Excellent, Sohan. This is an assignment statement. This is an assignment operator. The assignment will always happen in this direction, from right to left. Okay. So what happens in this line? If we do this, then X will also
20.
become equal to 20, right? And Y value will remain 20. Okay. And then in this line, there will not be any effect because both of them are anyway 20. Okay. So that's great. Now, Python as a language feature provides you an easy way to do that. So X is 20, Y is 10 now. I can actually do something like this as well. X comma Y is equal to Y comma X. And this will also end up swapping, right? So when you have in other programming languages, when you have to do swapping, you will invariably follow this kind of thing. Temp variable, third variable. But in Python, we never do things like this. We always do things like this. Okay, and this is just one of the examples. What I'm trying to say, Python code is inherently, you get a concise code. You get concise code. Okay, and it's not that with concise you lose the understanding. It's not like that. You very well can understand the code as well, and still it's concise. Okay, so can you see this? Any question on this? X comma Y, Y comma.
What if we have to swap 3 variables like X, Y, Z?
Okay, but in what order? So swapping generally will happen with 2, but you can do 3 also, right? So let's say we have Z is equal to 30, right? So X is 10, Y is 20, and Z is 30. We can do the same thing, X comma Y comma Z, and whatever values you want to store. Let's say Z value, you want, or let's say you want X value to become Y, Y value to become Z, and Z value to become X, isn't it?
Yes, sir.
So this will also work. Okay. So now
Okay.
X, Y, Z. So now you see all the values have been shifted, isn't it?
Yes, sir.
Right. So this will work. Now you may be wondering, hey, so for everything I have to do, I have to learn this kind of syntax. But okay, if I have to swap, do this. If I have 3 numbers to swap, do something like this. No. In programming, you don't have to mug things. You don't have to kind of memorize things. Yeah, by practice, you will start memorizing. Of course, you will start becoming more. It's like mathematics. Some of the formulas, of course, you know, because that's a mathematics feature. Same goes with programming. You don't have to memorize. So I cannot say, okay, so you know, in mathematics, multiplication, okay, 5 3s are 15. Okay, I'll remember this. 5 3s are 15. No, you like that. There are thousands of combination. How much you can remember? But if there is a process to it, how it works out, then you easily remember. Same thing goes with this. So this comes with a concept which we will cover in future. It's called tuple unpacking. Okay, you will understand how this is possible, that we are able to do the swapping like this. There is a principle behind it called tuple unpacking. When we come to that, we will understand this. Okay, but I just wanted to tell you that no, one neat, nice language feature, we generally do something like this. Okay, in Python, if you have to assign values. Not only that, you can say A, comma, B, comma, C. Even if you assign the values like 50, 60, 70, you can do something like this as well. Right? Okay. So all this is because of the concept called tuple unpacking. All clear, students?
Yes.
Okay. Fine. So swapping is done. Importing modules, I'm not sure if we covered it, but what happens is when you install Python, you get the whole programming language, you get lots and lots of features, lots and lots of modules, library, code for you to write efficient program. But the number of modules are so many that Python will not load everything in one shot. Okay, so what Python will load is for you language features and also some built-in functions that you can list using this command dir built-ins. Okay.
So these are the default one.
These are the default ones. No, I will say these are the built-in ones. You don't have to even import anything to start using it. Okay.
Yes.
So yeah, these are the functions which you can look into it. You will find that okay, print and input, which we have been using, all that is part of that. Okay. Now these are by default loaded on your memory. Okay, they are loaded on your memory. Whenever I started this Python shell or I start my program, this will be loaded on my memory. Okay. If you want additional feature, let's say I want to find square root of 25. What is square root of 25?
5.
It's very good. So if I have to find square root of 25, there is no square root function available in built-ins. How do I do that then? One way is I can write my own program, but this is finding a square root is such a common thing that somebody would have done it already. Okay.
So can't we just use power and reset to the power 0.5?
Yeah,
That.
very good. So that is using one of the arithmetic operators. We can do that. Absolutely correct. But there could be some other functions which are not available, right? For that, you may not have your variable also. So for that, you can import a module. Like in this case, I can import math. Right? Let's say you want a precise value of pi. And if I do the directory listing of math, you see, I'm getting all this. Fine. There is even a pi value which is available with you. And now, since I've imported this module, now to use this module, I have to say math dot. I have to use the module name dot. If I use, you see, I'm getting a more precise value of pi. And I have a square root function also. I can use math dot sqrt as well. Right. And I will get this square root. Right. So like that, these functions log 10 and then whatever is there is not available by default, right? But you can use math module. Now, why by default it's not loaded? Because your memory is limited, right? You don't have unlimited memory, right? You cannot load everything, all the modules in one shot. Even to load math module, once it loads it, or the whole math program will be compiled, stored. It will occupy some memory space, right? So for that matter, everything is not loaded on all the modules of Python is not loaded when you start the program. Okay, so these are the built-ins. You should actually remember this command. Now here you should remember this function dir. Dir is your friend. You can use that very commonly just to see okay what all contains. Like for math also, okay, what are the functions available? What are the functional constants available? Okay, these are the things which are available. So you can try them out. You see,
So is dir just directory or does it have another full form?
yes, a directory listing. Okay, it's just a directory list, dir. Okay, so if I say dir, if I say help on dir, there's a help function also. So it's a built-in function, dir object list of strings. That's what it will do. And it's called without an argument and return the same alphabets, right? So default, all that is there. So basically, that's what you. It's a built-in function, dir in the module built-ins. The purpose is to just list down all the elements, all the objects which are available to you, and even function or the constants or the values, all these are objects. It will list it out. Okay. So dir is the listing, to get the listing for your objects, and then help is to get the documentation. Let's say if I want to get documentation for math dot let's say tan. Okay, I can return the tangent of x. You get some documentation in this. Okay, so
Okay.
right. So so remember these two functions, and you should try this built-ins and try out these functions. What are the different functions? You may not understand everything, but whatever you understand or you're
So can I like add a library to the built-ins
you can create your
so
own.
that it's always imported?
So that is all this imported. You cannot modify built-ins because it comes with the Python altogether. There may be a way in which maybe you can extend it, but it will be only available for you. It will not be available for others. Okay, it will not be available for others. Probably there may be a way in which you can add it. And like built-ins is one thing. For that matter, if you want to add additional feature to math, maybe not. You may not be able to do it because this comes with a language feature. But your language feature may allow you to extend it in some way. So there may be a possibility to extend this. Okay, so if I want to extend it,
Yes.
there may be a possibility. You can check that out. Okay, so but yeah, of course you can create your own modules which can be available in your project. That is definitely you can do it. Okay, and if you
Yes.
are doing it, why would you want to really modify built-ins and math, and you would want to corrupt that? Instead, create your own module, create your own libraries. So it may be possible, but we generally don't do it. We will create our own modules, right?
Yes.
Okay, fine. So now, so this is basically the module. Now there are arithmetic operators. So we have, about plus and minus and multiplication and the division, right? These are available to us. You know about them, isn't it?
Yes.
Now, there are a few more. So I will tell you about modulus operator. Okay, modulus is nothing but it will give you the remainder. So what is the remainder when you divide 5 by 2?
1.
Yes, so this is what it is going to give. Okay, so if you divide 5 by 3, so modulus operator, also called remainder operator, is going to give you 2. Okay.
What about the percentage?
Yeah, so right. So what about the percentage? Percentage here, the purpose of the percentage is to give you that. If you want to calculate the percentage of the number, that's nothing but a fraction value multiplied by 100. That's what you get. So that kind of calculation you can always do. Okay. But here, this percent symbol has a meaning that it will give you the remainder operator if you're doing something like this. Okay. If you want to calculate percentage, I'm not sure if math provides you that kind of function in which it gives you the percent of something. There may be inbuilt function which may be available, which you can probably use to calculate the percentage. Okay, but percentage is as simple as you know how to calculate the percentage. Okay, now, okay, one more thing I wanted to tell you is that if you want to check out all the modules, you can use modules on help, right? So it is going to load all the modules which are there. This will take some time because it's going to list all the modules, and it's going to take a little bit of time. Okay, so let it load and we'll come back to this. When this loads, I will come to that. So
all the modules in the system, or all the modules in this instance of code?
All the modules of Python which are available for you. It will also include something which you have installed externally as well. And also all the modules of Python which are available by the programming language itself. Okay.
So did it already start printing them?
No, it's not. It's taking time because there are quite a few modules. Okay, so it will gather everything and then print it. Okay, so percent is clear. Modulus is clear.
Yes.
Okay, so it has loaded, and you can see that it has quite a few modules available. Okay, so these are all the modules available to us, and you can see that even the math probably is there. If I try to find Pygame, you see Pygame is an external module which I've installed and it's available to me. Okay. And if I search for MySQL, even MySQL is available to me. It's again an external module which I've installed. Other than that, yeah, there are like no PG for, yeah, this is for Postgres database. So these are the things which I have installed from external, and this is also available to me on my computer.
So why does some of them have an underscore before them?
Okay, so underscore ones are the protected and the private ones. You shouldn't be using them directly. Okay, so what happens is these will be used internally. Like the functools is there. There is another functools. So you should be using this functools. Never use underscore one, and also don't use the capital ones. Okay. So these are actually used internally in the language. So Python, a lot of things are driven through convention where we shouldn't be doing it. We shouldn't be doing it, and it is told to us by convention. But actually, you can pretty much call functools underscore functools also. There's nobody stopping you. But as a convention, that's why Python is much more expressive, much more powerful. And it does not puts a lot of restrictions on you. Okay, so but we follow a lot of conventions. So underscore things you don't call directly. It will be getting used by other modules internally. Okay, clear?
Yes.
Okay, good. Right. So now, so Modulus Operator is clear to you. Can you tell me any purpose of Modulus Operator? Where can we use this?
So like in real life.
Say any simple example, anywhere you would want to use Modulus Operator, other than, okay, if you want to find remainder, you will use Modulus Operator, which is also fine, right? If let's say if you want to find whether a number is an even number or odd number, a very simple example, isn't it?
Yes.
I don't know what is stored in X, but if I say X%2, so X is not defined in this. So let's say I define something 13, and if it's X%2, this is going to give me 1. Okay, which means, okay, X is odd.
So like while finding prime numbers to divide each of them.
Correct. So to find whether it's divisible or not, you can do that. So Y is even, and in that case, you can do that. Exactly. So prime number is another example where you will be required to use modulus operator. Okay, so the modulus operator is one thing. Then we have this power operator. And we have this power operator, which will actually also call exponential. Okay, exponential operator. And then it will be like 5 raised to the power of 2. What is 5 raised to the power of 2?